Next question, 12. The electromagnetic spectrum consists of waves with different wavelengths. Which row correctly identifies regions of the electromagnetic spectrum? First, list and organize the EM waves in numerical order for wavelength. Basically, all the options narrow down to just 4 EM waves: microwaves, X-rays, UV, and infrared. Back to your classroom notes. So here we have the EM spectrum, electromagnetic spectrum. So we start with, it doesn't matter which one we start, but in my class, the way that I explain, I start with radio waves, which has the longest wavelength, to gamma rays with the shortest wavelength, which means the sequence is showing a from long to narrow, so from high to low. So now I'm going to identify those 4 EM waves on my diagram: microwaves, X-rays, UV, and infrared. Microwaves, infrared, visible light is not included, and UV and X-ray. So look at the sequence: microwave, infrared, UV, and X-ray. So the X-ray is the shortest or the smallest wavelength compared to microwave. So I'm going to start with this one right here. So this is the wavelength, and this arrow indicates that is going from the smallest to the longest wavelength. Now, ultraviolet is closer to X-ray than infrared, so that will be my next one. So ultraviolet, and this that is missing must be infrared. Now this table here is organized from 10 to the negative 10 to 10 to the negative 2. So if you have your calculator, so 10 to the negative 2, 10 negative 2 is 0.1, and the 10 to negative 10 is this number: 1, 2, 3, 4, 5, 6, 7, 8, 9. I expand the 10 to the power to make it easier for you to see the difference in size of the wavelength from this number to this number. So now it's very clear that the options, they are organized by the smallest number of the wavelength to the largest number for this section. For this reason, D is the best option: X-rays, ultraviolet, infrared, and microwaves. There will be problems related to the sequence of the wavelength that you must remember the order. This is a typical example: visible light. So the visible light, we organize as from the longest wavelength to the shortest wavelength. So the range goes from 700 nanometer, which corresponds to red, to 400 nanometer, which corresponds to violet. So nano is 10 to the minus 9. So that is in meter. You must remember this range: red from 700 nanometer and violet 400 nanometer. And you need to memorize this order: red, orange, yellow, green, blue, and violet. So the extreme light, visible light spectrum starts from red and ends with violet. For this reason, the adjacent EM wave before visible light and after visible light is based on the colors right here. So before visible light, so because here we have the range of red, so that is our infrared. And right after the visible light, when the wavelength range is not in this anymore, it starts to get like 300, 200. So now we are talking about the ultraviolet. This is L. That corresponds to the violet color, and this corresponds to red color. So you must memorize this. The visible light before is infrared, right after is ultraviolet, and you need to memorize the order of the visible light from 700 to 400. So this has a longer wavelength and this has a shorter wavelength. Problem 13. A cathode ray oscilloscope, abbreviation CRO, is used to display the trace for a sound wave. The time base is set at 5 microseconds per millimeter. What is the frequency of the sound wave? So first, identify one complete wavelength on this graph. So I want to use this one, this. This is one complete wavelength. Just a note here. If you pick this from here to this, it's going to be very difficult to determine the size of this wavelength because you don't know very specific numbers between those boxes here. You just have the dimension of one complete box. So that's why it's better get a wavelength that hit all the beginning end of these boxes. Okay, so one complete wavelength, we have 3 boxes. These 1, 2, 3. A CRO display shows a wave in terms of time. So the problem provides that each box is 5 microseconds per millimeter. Okay, so to find the period, so the period is 3 boxes that corresponds to one complete wavelength times the time base for each box is 5 microseconds per millimeter. So the 3 boxes, each box in terms of length is 1 centimeter. So now the micro is 10 to the minus 6, and this means that over millimeter. Okay, so now we need to convert everything to meter. So 1 centimeter is 10 to the negative 2 meters. So 3 centimeters is 3 times 10 to the negative 2 meter. Times this, keep the same. Now millimeter is 1 times 10 to the negative 3 meter. Great. So now what we're going to do is cancel the units. So my answer is in seconds, which makes sense because period is in seconds. So to solve this, so what you do is we can start right here. If you have this type of calculator, works better this way. So 1 EE negative 3. Because it's on the denominator, I'm going to inverse this to multiply by 5 EE negative 6. Great. Now this result times times 3 negative 2. So now I have my result is 0.003015 seconds. So the problem is asking to find the frequency. So we have the period, the inverse of a period is the frequency. So now to invert this, you just invert this number. Now we have a 6,666.67 hertz. So this is my final answer. However, the options are this is not, so is one of those two here. So in both of them we have the prefix kilo. So kilo is 1,000 or is 10 to the third power. So if I'm going to convert this number manually to its prefix, so the decimal point is right here, decimal place. So I'm going to walk in that direction, counting 3, displace this point here 3 times. 1, 2, 3. So 6.6 times 10 to the third hertz, or using the prefix for this is 6.6 kilohertz, which is this answer right here. So this particular problem involves lots of things. First, how to read, how to identify a wavelength on a CRO display. Second, how to use the information from those boxes to convert into the number or the value that we are looking for. So that's explained here. Third is the relationship between frequency and period. And also how to use a prefix to display a final answer. Problem 14. So let's read. A transverse progressive wave is set up on a string. The graph shows the variation with time of displacement for a point on this string. The separation x, y on the graph represents the one of the options here, of the wave. X and y have equal to one of the options here. Which words correctly represents gaps 1 and 2? It's kind of fill the blank and gives you the options A, B, C, or D. So let me isolate this problem. First, I'm gonna look at 1 and then at 2. So for 1, we have here just 2 options. Is the period or the wavelength? So let's take a look. So from here to here, all right, we have the same distance, the same horizontal distance, which is, if we can place our ruler right here, we can determine that is 3.5. And if we spot one wavelength here, 3.5. So 3.5 and 3.5. So it seems to me these x and y is x, y, distance, horizontal distance, the one that I can determine with my ruler, horizontal distance, corresponds to the wavelength. So since the distance, the horizontal distance between x and y corresponds to a wavelength, a period is the time that takes for one wavelength to pass. Now, look the label for the x. So the label of the x is time. So the options here for 1 should be this or this, the time. If this was in meter, centimeter, and that will be the wavelength. But because here is showing time, so time is related to period. So one of those options. Now that we have this column 1, maybe, and those definitely no. So let's see what's going on the table 2. Okay, for the 2, we have to look at this way. X and Y have equal what? All right, so the options here are amplitude and displacement. Let's take a look what amplitude means. Amplitude is the vertical distance between the resting line or the equilibrium line to a crest or to a trough. So X and Y is not located on the crest or on the trough. So amplitude is not an option in this case. Now, one note here. Amplitude and displacement are different terms, but both relate to vertical distance from the resting line or equilibrium line. So the correct answer for this question is X and Y represents the time period, and X and Y have the same or equal displacement, not amplitude.